Hello guys, welcome to EMH 311. I'll be taking you the theories of matrices. The other time I share slides to the WhatsApp group, and I hope by now you have read through the slides. And I want to give this explanation so that if you have some areas that is not clear by watching this video, I believe you will have more better clarifications. What is the matrix? The theory of matrices arose as a means to solve simultaneous linear algebraic equations. Its present uses span the entire spectrum of mathematical ideas, including numerical analysis, statistics. Let's continue from there. Let me give you some matrix notations and terminology. A matrix generally is a rectangular array of numbers. Its order is the number of rows and columns that define the array. Let me present it to you in a way that you will understand better. When you have data or a set of number arranged in rows and columns, that kind of arrangement is known as the matrix. But in matrix case, it will be arranged in a parenthesis or in a square bracket. For example, look at this three example here. We have 1, 0, minus 1, 2, 5, and 7. They are arranged in a square bracket. This is known as a matrix. And this particular matrix has um, how many columns? It has 3 columns and 2 rows. And here is another matrix that has 3 columns and 3 rows. And also XYZ is another matrix that has just 1 column and 3 rows. And let me tell you one thing. The rows and column determines the order of the matrix. For example, determine the dimension of the matrix. For example, the first matrix here has a 2 by 3 dimension, while the second matrix here has 3 by 3 dimension, and the last matrix here, which has a what's it called, 3 by 1 dimension. So it's supposed to be 3 by 1 because it actually has a 3 rows and 1 column. Here's the general definition of matrix. Let's continue because of time. Notations and terminology in matrix continuations. Consider the system of the simultaneous equation presented here. Generally, this simultaneous equation can be represented as a matrix. The coefficients of the simultaneous equation, the equation 1 here, we have 2 minus 1, 1 minus 4, which makes the first row of the matrix. The second equation has 0, that's 1, 0 minus 1 is 0. As you can see that it contains only x1 and s3, meaning that the s2 and s4 are 0. So which is why we have 1 is 0, 1 is 0. And likewise, the equation 3 here has no x1, which means that the coefficient will be 0, and the s2 is 1, the s3 is 1, and also the s4 is 1, which is the coefficient of the matrix. And there's something we call augmented matrix. You can augment the matrix when you take the value here from this simultaneous equation. You will agree with me that we are not considering the value 1, 1, or minus 1. So by including all this set of value in a matrix, it will now form the augmented matrix. As you can see, we have the coefficient here, and we have the value to make it to be augmented. So I hope by now you understand what the augmented matrix is all about. Matrix notation continuations. What is a square matrix? A square matrix have the same number of rows and columns. Okay, when you have the same number of rows and columns, such is known as the square matrix. Matrix with half diagonal entries of 0 are diagonal matrix. What do we mean by that? We have diagonal matrix, and diagonal matrix can be upper triangular or lower triangular. For example, look at matrix here. Okay, you will agree with me that the diagonal is 1, 1, 1, and other value is 0. So in this case, we call this kind of scenario a unit matrix. As you can see in this case, this is a square matrix. The first matrix here is a square matrix, and it's not only a square matrix but a unit matrix. A unit matrix simply means 1. If you use unit matrix to multiply another matrix, you are going to get another, that means the same matrix. For example, if I say 1 times 10 is going to give me 10, 1 times any number is going to give me that number. The same thing is applicable to matrix. When you use unit matrix to multiply any other matrix, the result will be that same matrix. So unit matrices are the matrices that has their diagonal to be 1, and they have their diagonal to be the same or 1, while the rest entries in the matrix are all 0. As you can see here too, we have 1, 1, 1, and the other value here, upper triangular here is 0, and lower triangular here are 0. So by now, you should understand what upper triangular matrix is all about and lower triangular matrix is all about. Upper triangular matrix are the one that has the the entry below the diagonal to be 0. As you can see, here's the diagonal, and you know the entry below the diagonal are 0, while the lower triangular matrices are the one with off diagonal matrix lying above the diagonal to be 0. Here we have those entry above the diagonal to be 0. This is also known as a lower triangular matrix. Please take note of all these notations. You are going to be applying them shortly. Let's continue. The arithmetic of a matrix. When you see matrix, you can think of matrix as a number where you can add, you can subtract, you can multiply, and you can equally divide. Okay? You can do the same thing with matrix. Let's consider this matrix A and B. We have the entries. You will add the matrix together based on their entries. For example, you can only add A11, B11, A12, B12, and so on like that. Okay? If you are also dealing with subtraction, you will do the same thing. Look at the example I gave here. We have 1 plus 1, 2. We have 2 plus 0, 2. Minus 1, minus 1, minus 2. 3 plus 4, 3 plus 1 rather, 4. Equally, 1 plus 1, 1 plus 2, 3. 3 plus 4, 3 plus 1, 4, and 1 plus 1, 2. You go to the second row, 2 plus 5, 7, 1 plus 0, 1, 0 plus 2, 2, and you go to the third row, 1 plus 1, 2, minus 1 plus 2, 1, 1 plus 1, 2. So that's the way you will add your matrix together. Let's continue from there. Okay, there's something we call transpose of a matrix. Transpose of a matrix is very simple. Transpose simply means that you take the row and you convert the row of a matrix into a column. That's what transpose of a matrix is all about. For example, look at this first row. The first row here is 2, 0. The second row is 3 minus 1. The third row is 1, 1. And the fourth row is 0, 0. If you want to write this matrix A as a transpose, the result is going to be 2, 0, 0. You convert the row into a column. The first row, which is a 2, 0, is going to be 2, 0 here. The second row, which is a 3 minus 1, is going to be 3 minus 1 here. The third row, which is 1, 1, is going to be 1, 1 here in a column. And the fourth row, which is 0, 0 in a row, is going to be 0, 0 like this in a column. So that is the transpose of a matrix. Don't forget. What is a symmetric matrix? A matrix A is symmetric if the transpose is equal to the original matrix. This is telling you that if you transpose a matrix and you get the same matrix, such scenario is known as a symmetric matrix. However, a matrix is anti-symmetric if the transpose is equal to the minus of that same matrix. Look at this example here. Look at the example here. Sorry. Okay, here's the example. If we transpose this matrix and multiply by -1, you are going to get the original matrix. Let's continue from there. Multiplication of a matrix, leave this side. How do you multiply a matrix? Okay, matrix multiplication can be confused sometimes, but if you pay closer attention to it, it's very, very simple, very, very easy. Okay, if you want to multiply two matrices, let me give you the solution I have here. You have matrix 1, 2, minus 1, 2, and minus 1 and 3, 1, 0, minus 1 and 1. How do you multiply these two matrices together? Very simple. It simply means that you take the first row of the first matrix to multiply the first column of the second matrix. The first row of the first matrix here is 1 and 2, and the first column of the second matrix here is 1 minus 1. How do you multiply? This is going to be 1 multiplied by 1, 2 multiplied by minus 1. Okay, when you say 1 times 1, you have 1. If you say 2 multiplied by minus 2, you have minus 2. Okay, when you do this, this will now be the new entry of the new matrix. I mean the first entry of the new matrix. Similarly, if you want to get the second entry, you take the same row to multiply the second column from the second matrix. You know, the first row is 1 and 2, and the second column here is 0 and 1. You now say 1 times 0, which is 0, 2 times 1, which is 2. You add it together. Similarly, you will come to the second row. All right, the second row of the first matrix is minus 1 and 3. You now take it to multiply the first column of the second matrix, which is 1 minus 1. That is minus 1 times 1, you have minus 1. 1 times minus 3, you have minus 3. You add it together, you get your result. Similarly, you take the first row or the second row of the first matrix to multiply the second column of the second matrix. The second column here is 0 and 1. That is, this is going to give you minus 1 times 0, which is 0, and 3 times 1, which is 3. When you add this together, you will have your result here. It's very simple, as I said. I will give you this exercise to try. Please do this exercise for your own sake, because if you think it's very simple, if you are doing it on your own, it's likely that you get some challenges, but by looking at the explanation I gave you, you'll be able to understand how you are going to unravel it. Let me just give you the hint. The first row or the first matrix here is 1, 3, 1. The second row is 2, 1, 0. The third row is 1 minus 1 and 1. For the second matrix, the first row column is 2, 5, 1. The second column is 1, 0, 2. The third column is 1, 2, 1. As I said earlier, if you want to get the result for this matrix multiplication, you are going to take the rows to multiply the rows from the first matrix to multiply the column. It means you are going to take 1, 3, 1 to multiply 2, 5, 1. Okay? After that, you are going to take 2, 1, 0 to multiply 1, 0, 2. After that, you are going to take 1 minus 1, 1 to multiply 1, 2, 1. Then you get your result. Please do it and post your result to me. Let me see who get the answer. Let's continue from there. And I have several other examples of matrix multiplication, which I will want you to try by yourself. Here we have 2, 3 minus 1, 0, 1, 4 multiplied by 2, 3 minus 4. You can try it and let's see your result. I'll give you a lot of information for the matrix multiplication. But in the case you are still finding it difficult, kindly let me know. That is why I am here, to teach you, to let you understand what all these things are all about. And let's continue from there. I have talked about the addition of a matrix, multiplication of a matrix. Now let's go to the inverse of a matrix. I know some of you might be getting confused right now because you might not heard of inverse. Okay, let me just put it this way. In arithmetic operation, we have addition, multiplication, subtraction, and divisions. Let me just give you this way. The division in traditional arithmetic operation is the same thing as inverse in matrix, because we don't really have division in matrix. The alternative is inverse. You can think of inverse of a matrix as a division that you have in your arithmetic operation. So that said, the square matrix A is not singular. Okay, what do we mean by non-singular? When a matrix is non-singular, you are going to have better understanding later on. When the determinant of a matrix is equal to 0, it means that that matrix is singular. Please, I repeat, if the determinant of a matrix is equal to 0, it simply means that the said matrix is singular. But if the determinant is not equal to 0, it means the matrix is non-singular. Sometimes they may ask you to prove that a given matrix is singular or a given matrix is not singular. Kindly find a determinant, and the result that you get from the determinant will enable you to make a decision whether the matrix is actually a singular or not. Before you can talk about the inverse of a matrix, you have to understand well what the determinant is all about. But just don't bother. I want to talk about the inverse first. You still have better understanding, because we are actually going to use a reduced row operation to carry out this work. Let's continue. The square matrix A is not singular or has an inverse or is invertible if there can exist a square matrix B such that A multiplied by B is equal to B multiplied by A is equal to I. Don't forget that I said that I is the same thing as a unit matrix, and a unit matrix simply means 1. Imagine you are saying 2 divided by 2, what are you going to get? You are still going to get 1. That is what they are saying here. They are simply saying that if you have the inverse of a matrix and you multiply the inverse, okay, with the original matrix, the result is going to give you 1. I hope you understand. When you have a matrix and you calculate the inverse for that matrix and you use the same matrix to multiply the original matrix, you are going to get 1. Alright, because inverse simply means the division of the matrix. So we call the matrix B the inverse of A, and is denoted by A raised to the power minus 1. A matrix that is not invertible, that is one for which inverse does not exist, is called singular or non-invertible matrix. For example, the following are singular matrices. Matrix A, B, C, they are all singular. As I told you earlier, if you want to determine whether a matrix is singular or they are not singular, you simply find their determinants. I can see right from here that the determinant for all these matrices will be 0. Okay, but I will not tell you how I got them right now. Okay, but you are going to understand better later. So all these matrices are singular because their determinants are 0. Let me give you this first example. Find the inverse of A. Find the inverse of A. Find the inverse of A. Don't forget that if you want to find the inverse of A, you simply say A, that is the original matrix A, multiplied by inverse will be equal to 1. As I told you, I have given you that scenario here earlier. Okay? If you multiply A by A, if you multiply A by A inverse, you are going to get 1. What is A? A is this, and this is A inverse that you are looking for. But don't forget that this I is the same thing as 1, 0, 0, 1. They are unity matrices. I have given you somewhere here. I have given you that somewhere here. What is it called? Let me go. As you can see, I here, they are unit matrices, and they are the same thing. Is the same thing as 1. Take notes. Take notes. ask question if you don't understand, and comment. Where are we? Okay, all right, here. So here is the original matrix. If you want to find inverse, you simply say A multiplied by A inverse is equal to I, where I is unity matrix. Here is your A. Here is the A inverse that you are looking for, and here is I 1 0 0 1. The next thing you can say that A inverse to be equal to ACBD. You can represent your A inverse to be ACBD. In that case, you can convert this expression like this: 1 2 minus 1 1. AB is equal to 1 0, and 1 2 minus 1 1. CD equal to 0 and 1. All right? Or better still, do you still remember the example I gave you under augmented matrix? You will agree with me that this matrix A will form the coefficient of a simultaneous equation, and the equal to parts that you bring into the matrix to form the augmented is the same thing as this: 1 2 minus 1 1 1 0 1 1 0 0 1. So this is augmented matrix. This is the augmented matrix. I gave you the example of augmented matrix earlier. Okay, I gave you the example of augmented matrix earlier. Go back to from where we beginning. You will see what the augmented matrix is. Under here, I want to introduce you to another aspect, which is called reduced row. Okay, row reduction rather. In matrix, there are many ways in which you can find the inverse, but I want to introduce you to the simplest method that you can apply to obtain the matrix inverse. It is known as the reduced row. You will reduce, I will tell you how you are going to do that. It's very simple. Okay, the idea is that all this value here, all the value from 1 0 0 1, you want to take them to the beginning to the beginning of the matrix. 0 1 0 1, you want to make it look like this: 1 0 0 1. You want to put it to this right hand side. You know, they are currently at the left hand side. You want to bring them to the right hand side, as in this case. How you are going to do that? You use method known as reduce row. What do I mean by reduce row? If you want to do this, first of all, you will look at the first row here, and you will make sure that all the numbers, all the entries under the first column in the first row here are 0. And you will agree with him that the only number under the first column is -1. You are going to make sure that this number turns to 0. How are you going to do that? I can do that if I say row 1 row 2 row 2 plus row 1, because row 1 here, the first entry in the row 1 is 1, and the second entry in the row 2 is -1. If you plus them together, you are going to have 0. If you say row 2 plus row 1, you are going to get 0. I repeat, row 2 plus row 1, you are going to get 0. So let's do it. Let's do this. Here I have I have let's say 1 and 1 plus -1, you're going to have 0. I hope you understand that. You're going to have 0. What am I doing? What will I do to make you understand this thing better? You're going to have 0. Okay. I have jumped a step here. I have jumped a step here. Okay. I have jumped a step here. I have jumped a step here. Okay. I want to make sure that this value, I want to make sure that 2 here is equal to 0 and minus 1 is equal to 0. That is what I want to do. I want to make sure that 2 is equal to 0 and minus 1 here is equal to 0. If I do that, it's going to look exactly like this. I can achieve that by adding row 1 and row 2 together. If I do that from here, this here will give me 0. But how am I going to make 2 here to be equal to 0? I've jumped a step. Okay, let's go to another example. I will give you better explanation on how to achieve that. Don't bother. Let's take this example and find the inverse. The inverse for this matrix, matrix A, or what? Okay, the inverse for this matrix A can be getting. I have solved it for you from here. Remember that if you want to get the inverse, this is a 3 by 3 matrix. If you want to get the inverse, you are going to use a unit matrix equal to 3 by 3 in dimension. So it means you are going to use 1 0 0 0 1 0 0 0 1 as in this case to form your augmented matrix. After forming your augmented matrix, you now proceed to reduce your matrix so that you will have something in this form at the end of the day. I've solved it for you here. Here is the row 1, row 2, row 3. First of all, my row 1 is okay. I don't have to do anything with my row 1, but I have to make sure that all the entries under row 1 are 0. If I want to make sure that 2 is equal to 0, I can do that by saying row 2 minus 2 row 1, which means that if you say row 2 minus 2 row 1, if you multiply row 1 by 2, then subtract it from row. If you multiply row 1 by 2 and subtract it from row 2, this will make these two to be 0. And why are they applying 2 here? They are applying 2 because they know that if they have 2 here, it means that if they have 2 here, it means this first entry and the second entry here, we have the same coefficient, and that will make it to be very easy to become 0. Just remember the way you solve simultaneous equation, where you will use arbitrary number to multiply one simultaneous equation in order to make sure that the coefficients are the same. It's still the same ideology that they are applying here. Simply multiply row 1 by 2 and subtract it from row 2. In that case, you are going to have 0 here. You are going to have, since we are multiplying row 1 by 2 and we are adding it to row 2. So in this case, we have 0. Here we have 0. We have 2 multiplied by 1, making minus 2, 2. 1 minus 2 minus 1. 2 multiplied by 2. 2 multiplied by 1, making 2. 0 minus 2 minus 2. 0 multiplied by 2, making 0. 1 minus 0, 1. 0 multiplied by 2, making 0. 0 minus 0 is 0. I hope you understand. So you have your 0 here. Similarly, you can make the third entry in the first column here to be 0, because I told you that all the value under 1 here will become 0. How do you do that? This is very simple. You can simply say that row 3 minus row 1. Since they have the same coefficient, you don't have to add any, you don't have to multiply it with any other arbitrary number. Simply say that row 3 minus row 2. So 1 minus 1. 1 minus 1 is 0. 1 minus 0, 1. 2 minus 1, 1. 0 minus 1, minus 1. 0 minus 0, 0. 1 minus 0, 1. Now that you have all your value here to be 0, cool, that is good. Remember, this is 0, that is okay. You want to make sure that this 1 becomes 0. By now, I hope you understand where we are going. We want to make sure that they look like this. Okay? So how am I going to make sure that this 1 is equal to 0? I can say from here, From here, I can say row 3 minus row 2. Because we have 1 here, we have 1 here. If I minus this one and 1, I'm going to get 0. So I can say row 3 minus row 2. I have 0. I have, since we are minusing, minus 1 minus 2. Wait to here we have, okay, that's correct. 1 minus 1 making 2, minus 1 minus 2 making 1, 0 minus 1 making minus 1, 1 minus 0 making 1. That is correct. By now, the thing is taking shape. It's actually taking shape. Yeah, it's taking shape right now. It's taking shape. Yeah, it's taking shape right now. This is what I have. This is what I have. This is what I have. I want to make sure that this is equal to 1, because we're actually looking for things like this. I can divide row 3 by 2 so that here we will have 1. Divide row 3 by 2. If you divide row 3 by 2, you're going to have 1 here. Yes, it's taking shape. Who can tell me what next? The next thing is to make sure that minus 1 here and 1 here becomes 0. Okay? How are you going to do this? Very simple. If you want to make this one to become 0, you cannot add row 2. If you add row 2, it's going to spoil your work because it will make this value here to become 0. You can only add row 3. Add row 3 minus row 3 from row 1. It will make this to become to 0. Okay? That is 0, 1 minus 0, 1. 0 minus 0 is 0. 1 minus 0 is 0. Okay? 1 minus half, 0 minus half, half, 0 minus half. So therefore, we have 0 here. It remains here 1. Here 2 has to become 0. Similarly, you can say that row 2 plus row 3, if you do that, you are going to have 0 here. You know, it's simple. You agree with me. It's very, very simple. Very simple. Please walk over it. Look at this video. Watch it again. If you have any question, please let me know. If you want me to explain some things that are not clear to you, kindly simplify. I will do that joyfully. Now, let's go to the determinant of a matrix. I have told you that determinants can be used to determine whether a given matrix is singular or not singular. So, when you want to obtain the determinants of a matrix, simply think about the operation we carry out under inverse of a matrix. Okay, in determinant of a matrix, you can carry out the same procedure. However, you are not looking for the matrix to result into a unique matrix that is I. Okay, though you are still going to reduce, but you are not actually after. You are not after the matrix to become a part of the matrix to become a unique or identity matrix. Let me give you this theory. If two rows or columns of a matrix, if two rows or columns of A are interchanged to form A, then the determinant of a matrix A is equal to the determinant of the A transpose. If a row or column of A is multiplied by alpha to form A, then alpha multiplied by determinant of A is equal to determinant of A transpose. If a multiple of one row or columns of A is added to another row or column of A to form A, then determinant of A is equal to the determinant of A transpose. And finally, if A, please note this third rules. That is the most important aspect of this theory or of this rule. Okay, if A is either upper or lower triangular with diagonal entries alpha 1, 1, alpha 2, 2, alpha n, n, then the determinant of matrix A is equal to the multiplication of the diagonal. So basically, if you want to obtain the determinant of any matrix, you can reduce the matrix to form a upper triangular or a lower triangular matrix. And when you do that, you now multiply the diagonal of such matrix, and the result will give you the determinant of that matrix. And the fourth rule is that A is singular if and only if the determinant of A is equal to 0. Now, let's give you some example. Look at this example. Calculate the determinant of A using row operation. As I told you, we are using row operation here. Calculate the determinant of A using row operation. Giving A to be equal to 0, 1, 1, 1, 0, 0, 0, 0, 1. How are we going to do this? Very simple. I hope you've not forgot your the way we obtain the inverse of a matrix. You know what lower and upper triangular matrix is all about? Let's try and convert this matrix to upper triangular matrix. So it means that if you want to convert it to upper triangular matrix, look at this entry. All the value under this entry will become 0. After that, you go to the second row, and for the second entry in the second row, all the value under this entry will become 0. When you are able to do that, you now multiply the diagonal 1 minus 1 and 1. That will give you the determinant of your matrix. Very simple. I believe you can do this very easily in the exam. Okay, if you want to make sure that the value here becomes 0. Before we actually get started, you know that the first value here should not be equal to 0. The first value here should not be equal to 0. So if I want to make this value to be something, I can just add the matrix, I can add the second row to the first row. That's what they did. Add the first row, add the second row, 1, 0, 0 to the first row rather. If you do that, you're going to have 1, 1, 1, and it still remains the same. 1, 1, 1, 1, 0, 0, 0, 0, 1. So this is cool, this is okay. And I want to make sure that this one with my culture here is equal to 0. If I want to do that, I can say row 2 minus row 1. Row 2 minus row 1. It means you are going to subtract row 1 from row 2. If you do that from here, you are going to have 0, 1 minus 1 is 0, 0 minus 1 minus 1, 0 minus 1 minus 1. Okay, I have 0 here, and luckily for me, I have 0 here already. I will not do anything since there's 0 here already. I can't do anything. But here, I have 0 here too. I can't do anything. So you multiply the diagonal. That will give you the determinant. Let's see the second example. The second example is saying that calculate the determinant of A, where A is equal to this value 1, 2, 1, 3, minus 1, 1, 3, 2, 1, 0, 2, 3, minus 1, 1, 1, 4. I'll give you the solution here. Look at it very carefully. Look at the solution. My row 1, row 2, row 3, row 4. As I told you, I want to convert this matrix into a upper triangular matrix. It means this is the upper triangular matrix. Here's the diagonal. Here's the diagonal. And the value below the diagonal becomes 0. All the value below the diagonal becomes 0. Here's the diagonal, as you can see, 0, 0, 0. I want to make sure that all these values become 0. I've done that. That's what we are going to do. Look at this very step, very simple. Even if you look at this picture or this picture without explanation, I believe you should be able to get the answer. But however, if you are still finding it difficult, ask questions, ask your colleagues. You can directly ask me as well. The first one is okay, it's cool, you don't have to do anything. I want to make sure that all the value under this column are 0, all the value here are 0. That's what I want to do. All the value here are 0. Okay. I can say row 2 plus row 1. Row 2 plus row 1, add it together. Minus 1 plus 1 is 0. 1 plus 2, 3. 3 plus 1, 4. 2 plus 3, 5. If I want to make sure that this value is equal to 0 under with row 3 here, the first entry under row 3, this value is equal to 0. I can do the same thing, row 3 minus row 1. That is 1 minus 1 is 0. 0 minus 2 minus 0 minus 2 give me minus 2. 2 minus 1 give me 1. 3 minus 3 give me 0. If I want to make sure that this minus 1 becomes 0, I can add it to row 1. That is row 4 plus row 1. We have minus 1 plus 1 is 0. 1 plus 2, 3. 1 plus 1, 2. 4 plus 3, 7. After I'm done with that, it's not yet finished. I'll make sure that minus 2 and 3, minus 2 here and 3 here are equal to, are converted to 0. Okay, minus 2 here and 3 here are converted to 0. And after that, I'll still go and make sure that this entry here, this entry here is also equal to 0. If I want to convert 3 to be equal to 0, please be very, very careful, because sometimes you don't just take any rows and columns and add them together. If you do it wrongly, you are going to get confused and you are never going to get to the final answer. I've already seen that I want to convert minus 2 to 0. How am I going to do that? Of course, I cannot use row 2. I cannot use row 1. If I use row 1, it's going to spoil everything. I will advise you to use row immediately above the concerned entry you want to convert to 0. Okay, here's minus 2. Okay, I will advise you to use row 2 here in order to convert minus 2 to 0. How are you going to do that? You can get this thing done if you multiply row 2 by 2, okay, and divided by 3 is going to give you 2. Here, that if I say 2 times 3, that is 6. 6 divided by 3, which will give me 2. So which means that I can say that row 2 multiplied by row 2 divided by 3, I may not consider that if this 3 is equal to 2, that will enable me to add them together so that this value here can be converted to 0. All right. Say that row 3 plus 2 row 2 divided by 3. Okay. That is there. 2 multiplied by 3, which give me 6. 6 divided by 3, which give me 2. 2 minus 2. I have, I'm actually adding them together, but there's minus there. 2 plus minus 2 will give me 0 here. I will continue. 2 times 4, making 8, divided by 3, that is 8 divided by 3 plus 1, which is going to give me 11 divided by 3 here. I can equally say 5 multiplied by 2, which is 10, divided by 3, 10 over 3 plus 0, which gives me 10 over 3. I'm done with this row. I will now come to this side. How am I going to convert this to be equal to 0? How am I going to convert this to be equal to 0? Let's continue. I'm saying that if you want to I corrected something. I put 3 here earlier, and I noticed that there's not supposed to be 3 there, so I have to remove so that you will not get confused. So if you want to convert for this place, I can say that row 4 minus row 2, that is 3 minus 3, give me 0 here. 2 minus 2, 2 minus 4 give me minus 2. 7 minus 5 give me 2. So I have converted all the value here to be equal to 0. And lastly, I have to make sure that this minus 2 becomes 0. This minus 2 becomes 0. I am done with row 1, row 2, row 3. It remains row 4. Under row 4, I have to make sure that this minus 2 becomes 0. Okay, if I can make this 11 over 3 to become 0, to become 2, that will make my work to be very, very easy. If I can make 11 over 3 to become 2, if 11 over 3 becomes 2, that will make this thing to be very, very easy to solve. So in order to do that, I can say that row 3 multiplied by 6 over 11, because I noticed that if I say 6 multiplied by 11 is going to give me 2. I hope you get it. Take your pen and do some little calculation. You will get it very well. So I can now say, since I have minus 2 here, I can add them together. I can say row 4 plus 6 over 11 row 3. If we do that, we know here we have 2 here already. So this is going to give me 2 here. If I say 6 over 11 multiplied by 11 over 3, this is going to give me 2. I can now say 2 minus 2 here plus 2, making 0. And don't forget to do this one also. You can now say 6 over 11 multiplied by 10 over 3. If we add the two together, you're going to get 42 over 11. Now, you are done with the row reduction to upper triangular matrix. All the value here under the diagonal are 0. And you will remember the third rules of determinants, which says that when you have an upper triangular matrix, you multiply the diagonal, and when you multiply the diagonal, the result will give you the determinants. As you can see in this case, you multiply this value in blue color, you multiply them, and when you do that, you have your the result to be equal to 42. So for this case, your answer is equal to 42. Please go through it again, watch this video. If you have any challenges or if you have any question, kindly signify. In the next video that I'm going to be sharing with you, I will walk you through the eigenvalues and eigenvector, but I will urge you to kindly go through these materials and video first, and after that, in the next 3 days, maybe by tomorrow or latest by Monday, I'm going to share with you the second part for this explanation. Thank you very much. Have a lovely uh, have a lovely weekend there. Bye.